This is ethyne, the first member of the alkyne homologous series. Now, this is the full question where we are going to be seeing addition of hydrogen to ethyne. Now, this is going to give us two-step reaction, where the first reaction is going to give us the product X, and then the second reaction will give us the product Y. Now, let us briefly discuss the addition reaction of alkyne. Alkyne has 3 bonds, and these 3 bonds are made up of 1 sigma bond and 2 pi bonds. Now, what happens is that in the addition reaction, the first reaction will involve the breaking of the first pi bond. 1 pi bond will be broken so that it will give room for addition of what? Hydrogen to form an alkane. Then the second reaction will now involve breaking of the remaining pi bond. Remember I told you that it is made up of 1 sigma bond and 2 pi bonds. The second reaction will involve breaking of the second pi bond to now give rise to the saturated compound, which is the alkane. All right, so let us see what this thing will lead us to. The first addition reaction will result to what? Breaking of what? One of these bond to yield what? 1 hydrogen will be given to this particular carbon. The remaining hydrogen will be given to the second carbon. Now, at this point, what we have here is the ethane or ethane. Then this ethane is also unsaturated. The purpose of this reaction is to attain stability, in which case this ethane will still have to undergo a further step reaction to lead towards formation of an alkane. In this case, we are going to be having what? The ethane as the final product. Now, this is what our X is. This is our value for X. Then the second reaction will be still adding what? The hydrogen. This process of reaction is called hydrogenation, process of adding hydrogen. This will lead us to breaking of the second pi bond. Now, this is the first carbon having the first and this and this. This is what we have at this point, which is the same thing as this ethane. Now, by the time we break the second and the last pi bond, we will be forming an additional hydrogen atom here, and then the other one will be bonded to this. This is the last product, which is what? The ethane. Now, where this is your X, this is your Y. I hope you learned something here. Then I will go further to explain what addition reaction of alkyne is in detail, because there are other things apart from this question that I extracted. There are other ways that alkyne will be added to probably hydrogen, which we have done here. Then we can see addition of a halogen. Then we can see addition of hydrogen halide. Then lastly, we will see the addition of water. All right. So, but the same thing will occur virtually in all of these examples I've given you here, I've mentioned the addition of hydrogen, which is what we have done here. The same reaction or the same pattern will occur when you are adding halogen. These are the halogens are these group 7 members, or you call them the salt formers. Then you can see the same process of reaction or method of reaction in the addition of hydrogen halide. That is when hydrogen is in a compound with the halogens. Then lastly, we are going to see the addition of water. When you are adding hydrogen, this is what happens. When you are adding halogens, halogens take two-step reactions too, but then you have to do this under the presence of a catalyst. Then when you do this reaction, it will enable the formation of, first of all, what looks like an alkane, because this process will first of all break the first pi bond, giving rise to one of the, I'm making reference to the halogens, one of the halogen atom to be bonded on one carbon atom, then the remaining one will be bonded to the second carbon atom, exactly in this format. Now let me see if I can quickly give you a short example. Now, assuming that what we are having is addition of, let's say, chlorine. Chlorine is a halogen. This will happen under the presence of a metallic halide, which will speed up the rate of what reaction. This metallic halide is serving as a catalyst here. Now, when this thing does not occur under the presence of a catalyst, it gives a different kind of reaction altogether. It will not follow this format, and then it will be explosive. It will be very explosive. So there is always need for us to control this reaction under the presence of a metallic halide. All right. So this reaction will first of all form, let's say we are breaking the first bond, the first pi bond. When we break it, we will introduce chlorine here, and then we'll introduce what? Chlorine on the second carbon. Now, this is what we call 1,2-dichloroethene. That is 1,2-dichloro what? Ethene. This particular compound is still unsaturated, so it will go further to do the second step reaction, in which case it will still add another chlorine that will eventually lead to the formation of a saturated compound, which is going to be, let's just draw what we have here. Let's just draw what we have here. This is what we have here, still 1,2-dichloroethene. So by the time it breaks the final pi bond, it will now give rise to what? Adding what? More of the chlorine here, and then this is the second chlorine attached. Now, this is the final product where we can say we have what? Achieved saturation. The name here is what? 1,1. When we number it this way, we have 1,1,2,2 tetrachloroethane. Let's do it together. We have 1,1,2,2 tetrachloroethane. Why do we have 1,1,2,2 here? The first carbon is carrying chlorine and chlorine here. So you are going to be mentioning chlorine twice for the first carbon. The same thing will occur for the second carbon. So we have 1 1 2 2. Tetra means 4. Tetrachloroethane. Now this is the final product when it is involving what? Addition reaction involving what? Chlorine. Or let's say that chlorine is representing all the halogens. This same thing will happen across all the members of the halogen, the iodine, the chlorine, the bromine, but they happen at different rates. Iodine may happen a bit faster, followed by bromine, and then this one will occur very mildly. Now, but the problem is that when you are doing this particular experiment involving addition of chlorine without using a catalyst to control the experiment, it will become explosive. Like it will become very, very dangerous because the reaction will be very fast. Okay. Now, the next thing we are going to look at is the addition of hydrogen halide. Hydrogen halide is when hydrogen is in compound with what? A halogen. Let's give an example using hydrochloric acid, or let's say hydrogen chloride gas, whichever one. Now, when we are adding HCl to this will also occur in the presence of a catalyst. Now, when this thing occurs, hydrogen will break the first bond, or let's say the first pi bond will be broken, and hydrogen will be attached to one carbon. Chlorine will be attached to the second carbon. Let's see what will happen here. We have this. This is our original ethyne. Now, when you break one pi bond, you will be having H here and what? Chlorine here. Now, this is still unsaturated because it has a double bond. All right. So the name is, let's say, chloro, let's say chloro what? Ethane. Sorry, chloroethane. This is what? Chloro what? Ethane. Then when you do the second reaction, where also HCl will be added to the chloroethane, this will give rise to the last product, which is a saturated compound. Let's still write what we have here. Now, when this thing occurs, the way you have to do this one is to make sure that chlorine also joins the particular carbon carrying chlorine. You will not just place it anyhow. Maybe you want to make hydrogen to be here, and then you make chlorine to be here. Then you have chlorine on the first carbon and also in the second carbon. This will be going against a law which we call the Markovnikov rule, that says that in adding a hydrogen halide, you must make sure that the halide is on the same carbon. Then hydrogen is on the same carbon. Now, in this case, chlorine will be, let's say we break this bond, chlorine will be added to the same carbon carrying chlorine, and then hydrogen will be attached to the carbon carrying hydrogen. This is obeying the Markovnikov rule, then making this thing a correct answer. So here we have what? 1 1 one what? Dichloro what? Ethane. This is your what? Final answer. Then the last thing we are going to be looking at is when you are going to be adding water to ethyne. This also occurs under the presence of a catalyst. In this case, you are not just using a metallic halide to serve as your catalyst, but we are using H2SO4, which is tetraoxosulfate 6 acid, and mercury 2 tetraoxosulfate 6. Now, when you use these two particular catalysts at a specific temperature, say 60 degrees Celsius, it will control the whole experiment and enable the addition of what? Water to what? Ethyne. And this will lead to the formation of a product, which is basically going to be in form of, is going to form an alcohol, which is at the point an isomer of an alkanal. In this case, there is a slight problem here where we will not definitely have one single product in that same system. The alkanal will be in equilibrium with the alcohol that is in same system. Now let us see what will happen when we are trying to add water in the presence of a catalyst. So what will be happening here is that the reaction is going to form an ethanol. Since we are working with ethyne, it will form what? An ethanol. Let's still have our compound ethyne here. Now, water is made up of what? Hydrogen and hydroxyl ion, right? Now, the hydrogen will be attached to one carbon when you break the pi bond. Then the other OH will be what? Attached to the second what? Carbon. So we'll have something like this. We have H, and then we'll have what? OH. OH. Now, when you are counting this, you see that you have 1 2 3 4 for this, 1 2 3 4 for this, making it complete. Now this particular compound is called the ethanol. Ethanol in here, giving respect to the fact that there is double bond here. All right, so all is a functional group that owns this particular compound, making it the homologous series. Okay, so this is what? Ethanol. This is the final product formed, but then I told you that it is still unstable and it is just an isomer of another compound that we call the ethanol. Let me write it here. So it is same thing with what we are going to be seeing here. Now, in this case, we are going to be having what? H and double bond O. Now, just follow me. This is it. I had to remove this because carbon is tetravalent and it must contain 4 bonds. In which case, this particular carbon will be having 1, 2, 3, 4. This one will be having what? 1, 2, 3, 4. This is the functional group we call RCHO, where R indicates an alkyl group. Then CH is what makes the functional group alkanal. Okay, so here we are having what? Ethanol. Ethanol, which is an isomer of ethanol, because this thing occurred as a result of what? Rearrangement of this ethanol. So it's not like it is a two-step reaction, just like we have in addition of hydrogen, addition of halogens, addition of hydrogen halides. Okay, this is different because this will be formed in the same system. This is also going to be formed in the same system. Then this is assumed to be more stable than this. However, this is the main product that is formed. So ethanol will be in equilibrium in the same system with what? Ethanol. So generally, this is the addition reaction of ethyne. I hope you enjoyed this class. If you have any question, you can send it to my WhatsApp number. My WhatsApp number is displayed on the screen, or you can just take it 090-230-14038.